Hello guys, Merker here. I'm just going to do a very quick video on Project Discovery. I'm going to try and go through this fairly quickly because there is quite a bit of content to talk about. However, what I'm going to do is I'm going to skip through all of those beginning tutorial windows because I found that the tutorials are very poorly done and they don't really explain how to actually go through Project Discovery. So I'm just starting here. I've skipped through all those intro windows and gone through the first cell sample so that we can have a look and see some of the stuff that's here. So if you look on the left, what you're looking at is what looks to be a fluorescence microscopy slide. So you have, I'm assuming that these are from a fluorescent microscope. You have fluorescent staining in 3 different colors: red, green, and blue. Now each of those colors stains a different component of the cell. So if I select only the red here for a second and zoom in, what you can see is that the red staining stains the microtubules of the cell. And you can see that that gives you a very good picture of the outline of the cell body as a whole. So if I turn that off and I turn on the blue, you can see that the blue staining is selective to the nucleus. And so the blue staining will always be selective to the nucleus here, and combined with the red staining, you have a very good picture of the cell and the location of the nucleus throughout the slide. Now, what you're asked to do in Project Discovery is to select on the right-hand panel from all of these categories. During the tutorial, it only gives you a couple options, but later on they'll all be available. And what you'll want to do is select what you think is stained by the green fluorescent channel only. So if I select this green fluorescent staining, you can see that it overlaps with the nucleus. It also overlaps with the cytoplasm, which isn't one of the options that's available to us here. But you can see that this section is sort of brighter than the rest of the cell. So you can see the whole cytoplasm there is the darker green dots stained around, and then there's this brighter section of green dots overlapping the nucleus. And what that indicates to me is that this is probably a staining of the nucleus. If you hover your mouse over each of the options in the right hand side, what it will do is it will give you a description and some example slides of what each of these things looks like. And there are a lot of things to choose from. So going through the tutorial examples at the beginning, I would advise you to read all of the windows and all that stuff that I skipped through, but they won't really tell you that you need to focus on the green fluorescent channel in order to score these. So that's one of the things that I really wanted to point out here. So what you want to do is use these in conjunction in order to score. So for example, I'm going to select nucleus here because I'm pretty sure this is not nucleoplasm. It doesn't look like nuclear speckles. Could be, but I don't think so. But we'll hit submit and see what happens. So I got that one correct. So we'll move on and look at another one. So you have here again, it gives you in the first couple of tutorial samples, you'll go through nucleus, and then after that cytoplasm, and then these other things: periphery, miscellaneous, and not identifiable. But if you hover your mouse over these, you can see that you have these examples, and they only show you examples with the tri-color staining, which is not super useful. But if I hover over this, you can see this looks very much like nucleoli fibrillar center. And what these are, if you read the description, it says clusters of small spots in the nucleoli, which are small, somewhat elongated circles overlapping with holes in the blue marker. So the reason that I wanted to read that out loud to you is so that you can notice that what you're doing is you're using the green fluorescent channel in combination with the other channels to figure out what these are. So if you read the description of this, we want to check to see if these green dots are actually falling within holes in the blue marker that stains the nucleus. And you can see if I just turn on the blue channel and then I turn on the green channel, those dots appear pretty much within these centers within these holes or nucleoli in the within the nucleus. Now this to me looks like it could be, I think it's this one. They're both nucleoli options. One is nucleoli, one is nucleoli fibrillar center. I'm going to select fibrillar center because these look like collections of small dots to me, rather than nucleoli, which are also located within holes in the blue staining, but sort of these larger sort of globs. But we'll hit submit and see what happens. And that was correct. So what you'll do is you'll go through the tutorial and try to do your best to read the descriptions that are given for each of these objects, and then go through and select the option that you think you're looking at and hit submit. The next thing that I want to talk about is the analyst rank, the accuracy rating, and the submission history. So on the left, your analyst rank determines the number of analysis credits that you get for each subsequent rank. So what I mean by that is, when you're starting out at analyst rank 1, after you complete a certain number of sections, you will gain enough experience that you will go up a rank. And when you go up a rank, you're awarded credits. So you're not awarded credits for every slide that you complete, but rather you're awarded credits for every rank that you go up. And each time that you go up a rank, the number of credits that you receive goes up. So you start out receiving, a couple hundred, maybe, credits at most, but by the time you reach analyst rank 50, you're receiving about 3,500 credits for each rank that you go up subsequently. The next thing is your accuracy rating, and this is determined by two things. Periodically, as you're going through after the tutorial, you will receive test slides, and those slides will essentially are designed to test your accuracy, and they look very similar to the tutorial slides here. You'll select what you think you're looking at, hit submit, and it will give you either a check mark or an X if you have selected the incorrect option. And if you've selected the correct option, your accuracy rating will go up. However, for the majority of slides, what's going to happen is you will hit something, you'll submit, and instead of getting a check mark or an X, you'll see a percentage. And what those percentages are indications of what other people have submitted for that slide. That slide will then go into your submission history, and you'll see the number here to the left. You see I have a 0 because I haven't submitted any community consensus slides yet. However, that number will go up with each slide that you submit. And what happens is those slides don't immediately affect your accuracy rating, and they make up the majority of slides that you're going to be submitting. So you submit those slides and they go into submission history, and they sit there until the community has enough people from the community have submitted answers for that same slide to come to a consensus on what components are being stained by the green fluorescent channel here. Now, why does your accuracy rating matter? The reason that it matters is because if you look underneath here, there's a bar. This bar will slowly go up with each slide that you submit. And every time you submit a slide, you gain a certain number of experience points. And those number of experience points are based on your accuracy rating. So if you have 50% accuracy and you submit a slide, you will get 50 experience points. So the higher your accuracy rating, the more experience points you will gain for each slide submitted. However, it's important to note that when you think about it, if you get your accuracy rating up to 100%, the most that you can get is double the experience points per slide submitted. So if you get your accuracy rating up, say to even 75%, getting it up to 100% isn't going to allow you to go up ranks that much faster. So what I would suggest when you are beginning is not to focus on your accuracy rating, but to focus on the number of slides that you're submitting and just trying your best to make accurate selections based on the staining, and to get as many analyst ranks up as you can. The reason that I say this is because most of the slides that you select will be not community slides, or sorry, not test slides, but they'll be community slides, and they'll go into submission history where they may stay pending for several days. So until a community consensus is reached on those slides, they won't affect your accuracy rating at all. And what that means is that your accuracy rating increases very, very, very slowly. So in order to get up to, say, like 85%, realistically, to get up to that, you will be at analyst rank 50, most likely, before you get your accuracy rating up that high. So I would recommend just going through and doing as many slides as possible and trying to make accurate selections as you go through to get your analyst rank up as high as you can. The last thing that I want to mention before I finish is that I've done the math and made a fairly accurate prediction, I think, that you need to reach rank 49 in order to obtain 75,000 analysis credits, which is the number of credits required in order to gain the most expensive item available from the Sisters of Eve LP store, where your analysis credits can be spent. So I hope that I've made it clear that what you're doing here is you're using the green channel to go through and identify the components of cells based on the green staining in conjunction with these other two fluorescent channels. So I would recommend going through the tutorial samples with that in mind to try to get as many of them right as you can, and then go through and start plowing through community samples. Of course, if you have any questions, feel free to leave comments on this video. If I've made mistakes and I'm not 100% sure that this is what we're supposed to be doing because it hasn't been explained anywhere, but I'm pretty sure I've got this nailed down. But if there are things that I'm missing or things that I have incorrect or just general questions, feel free to leave comments on this video and I will try my best to respond to them. So best of luck with your sciencing, and until next time.